Hi friends, once again welcome back in our educational channel, that is Precise Electronics. Friends, in today's video lecture we are going to study the application of operational amplifier. What is operational amplifier? It is basically high gain DC amplifier which is able to amplify both AC and DC signal faithfully. In today's video lecture we are going to study the application of operational amplifier, and in this lecture we are going to study linear applications of operational amplifier. Linear application. What is linear application? In linear application, output signal varies with input signal in linear manner. Means output changes with changes in input, and that change is in linear manner. That's why it is known as a linear application. Some of the linear applications are inverting amplifier, non-inverting amplifier, adder, subtractor, then integrator, differentiator, etc. And today's video lecture we are going to study inverting amplifier by using operational amplifier. The second types of applications are known as the non-linear applications. What is non-linear applications? In some applications of op-amp, the output characteristics is linear with the inputs. Means output changes non-linear with the inputs. So in non-linear application, the output change in output is non-linear with the change in input. That is non-linear application. And in linear application, the output changes linearly with change in input. Non-linear applications are comparator, then Schmitt trigger, clamper, clipper, logarithmic and antilogarithmic applications. Comparator, Schmitt trigger. These are the part of our syllabus. So in our video lectures we are going to study comparator as well as Schmitt trigger, while the clamper, clipper, logarithmic amplifier and antilogarithmics is a part of engineering syllabus. It is a syllabus of engineering students. In today's video lecture we are going to study linear application, and the first application is inverting amplifier. What is inverting amplifier? Op-amp has two input terminals, that is the inverting input terminals and non-inverting input terminal. If input signal is applied to the inverting terminal, this amplifier is known as inverting amplifier. And obviously in case of inverting amplifier, output is out of phase with the input, because this amplifier is used to invert the input signal. So output is exactly 180 degree out of phase with the input. If input is positive, output should be negative, and input is negative, output will be positive. That means it is 180 degree out of phase with the input. The circuit diagram of inverting amplifier is now going to be displayed on your screen. In this diagram, the input signal, that is Vi, is connected to the inverting terminals through input resistor Ri. The output voltage is feedback to the inverting terminals through resistor, that is known as feedback resistor, that is Rf. Non-inverting terminal, that is pin number 3, is directly grounded. The supply of plus minus 10 volt to 18 volt is connected to pin number 7 and pin number 4. Pin number 7 is a plus VCC, pin number 4 is a negative VCC, negative VE. So the supply of plus minus 10 to plus minus 18 volt is connected between these two terminals. Input signal is connected to the pin number 2, that is inverting terminal, through input resistor Ri. Friends, in this case, inverting terminal, non-inverting terminal is grounded. Non-inverting is grounded, hence the inverting terminal is considered as virtually grounded. It is virtually means it is imaginary. Actually, in actual practice, it is not grounded, but it is considered as virtually grounded. Hence, the potential developed at this point, that inverting terminal, is considered as 0 volt, because non-inverting is grounded, therefore inverting is virtually grounded. Now we have to find out the expression for the gain, how the gain is calculated. First of all, we have to find out the current flowing through input terminals, and that is considered as In. So what is In? In is given by using Ohm's law. So In is equal to V input, that is the input applied to the inverting terminals through input resistor Ri, that is V input or VIP input, minus V in. What is V in? That is a fraction of feedback potential developed across actual inverting terminal. V input is input applied to input resistor, and V in is a potential developed across the inverting terminals. The fraction of feedback potential will be developed across this terminal. That is V in upon Ri. Ri means the input resistance. So by using Ohm's law, we can find out the input current. That is our equation number 1. I in is equal to V input minus V in upon Ri, equation number 1. Similarly, the feedback current IF, the output is feedback to inverting terminals through feedback resistor RF. So we have to find out the feedback current. So feedback current IF is also calculated by using Ohm's law. So the formula for IF is equal to V in minus V output, because output is feedback. So V in minus V output upon the feedback resistor RF. So once again, by using Ohm's law, we can find out or we can calculate the feedback current, that is IF is equal to V in, that is potential developed across inverting input terminals, minus the output potential V output upon RF, that is equation number 2. But friend, what is V in? V in is a potential developed across inverting terminals, and due to virtual ground, this potential will be 0. So V in is equal to 0. Therefore, the equation number 1 and 2 becomes, as V in is equal to 0, so equation number 1 becomes I in is equal to V input minus 0. So minus 0 gets cancelled. So I in is equal to V input upon Ri, that is equation number 3. Similarly, IF is equal to minus V output, because 0 minus V output upon RF, 0 gets cancelled. So IF is equal to minus V output upon RF, that is our equation number 4. Equation number 3, that is I in is equal to V input upon Ri, and equation number 4 is equal to IF is equal to minus V output upon RF. And input impedance of op amp is very high. In case of ideal op amp, it is infinite. So as the input impedance of op amp is very high, the input current must be equal to feedback current. So I in is equal to IF, that is our equation number 5. I in is equal to IF, कारण काय आलं की तुमचा impedance जो आहे op amp it is very high. त्यामुळे जो करंट तुमचा इनपुट करंट असेल तोच तुमचा फीडबॅक करंट असणार आहे. That means I in is equal to IF. Now by substituting the values of I in and IF, that is equation number 3 and equation number 4. What is equation number 3? I in is equal to V input upon Ri. Equation number 4, that is IF is equal to minus V output upon RF. By substituting this value, we get V input upon Ri is equal to minus V output upon RF. Now V output upon V input is equal to RF upon Ri. आपण काय केलं, व्होल्टेज एका साइडला आणले, रेजिस्टर एका साइडला आणले, इक्वेशन्स बरोबर. सो V output upon V input minus V output, because V output is minus, so minus V output upon V input is equal to RF upon Ri. What is V output upon V input? It is a ratio of output voltage to the input voltage. So that is nothing but the gain. So the gain of the amplifier is given by A is equal to minus RF upon Ri. Minus sign is there. Actually RF आणि Ri च्या व्हॅल्यू तुमच्या निगेटिव्ह येणार नाहीये. RF फीडबॅक रेजिस्टर, Ri इनपुट रेजिस्टर. मग निगेटिव्ह साइन काय आली? कारण A तुमचा निगेटिव्ह आला, गेन निगेटिव्ह आली, because V output is negative, V output is a minus. So gain is equal to minus RF upon Ri, and this minus sign indicates the output is out of phase with the input. Output is 180 degree out of phase with the input. That means the A, that is gain, is equal to minus V output upon Vi. So gain becomes negative. That means if the input is positive, output becomes negative. If input is negative, output becomes high. That means if high input is applied, output becomes low. If low input is applied, output becomes high. So the gain of the amplifier is given by, it is calculated by using the formula Rf upon Ri, and there is a negative sign. This negative sign implies that output is out of phase with the input. So friend, that is inverting amplifier, in which we are going to invert the input signal. In next video lecture, we are going to study non-inverting amplifier. So friends, keep watching this video lecture. Bye, take care. See you again in our next lecture, in which we are going to study non-inverting amplifier, the second application of operational amplifier. So bye, take care. See you again in next video lecture. Bye.